Tonight's lecture is going to be about making this object to our right, which I'm calling 15 of 24. Why? Not because I'm a Star Trek fan, but because it's the 15th slide out of 24 slides. So, if we look on this side, this is Solidworks 2018. That's what we're going to use to make this. The students in front of me actually have this drawing in front of them. It has a nice large printout. Those of you looking at this online, let me do this for you for a minute or two. Take a screenshot of this, and then we can start. Okay? I'm going to minimize this now and put it off to the side. I actually have a print in front of me as well, a nice printout. So here we go. I'm trying to zoom in on it. Nah, let's not zoom. Let's try that one more time. All right, there we go. All right, this object, with doing this drawing, you're actually going to learn how to do a revolve in AutoCAD. So you're going to evolve into revolve. You start a new drawing. It's going to be a part file. I actually already started a drawing in inches, and it's using inch units. But in case you've not done this, all you got to do is go over here, go to Tools, near the bottom, under Options. You can double check what your settings are, so you can go to Document Properties. My drafting standards will be ANSI. Okay, my units is in inches. That way I'm in the correct units. You want to make sure you're in the correct units of measurement. You don't want to mess that up. It's extremely annoying to fix a drawing that's in the wrong units of measurement. First thing I always recommend you do is turn on all your planes. Next, respecting the cube as I call it, the isometric cube. The front of the object is here. The right side is this side. The top is looking at it straight down. Ironically, this is a symmetrical part, so the front and the right side look the same. So when we do the detail drawing on this particular project, we might not do 4 views, or 3 views. We might actually try to get away with 1, maybe. We'll see when that time comes. But for now, appreciate that this is symmetrical. So you can actually start on the front plane or the right plane. It really doesn't matter. I'm going to start on the front plane and create my sketch there. I did outline all of this for myself, as I imagine you guys have done in front of you. I can't do this on the big screen, though, at least not using the product I currently have access to that I'm using to make this video. So when you look at the cutout, what you're trying to do is make the shape of the entire object without these top cuts, okay? Without these top cuts up here, without these top cuts out here, okay? So when I look at this, I don't think the highlighter is going to work on this, okay? Let me see if I could try something else real quick. I'm going to try and snip this out of here and put it into Word. Maybe that'll allow me. There we go. That'll work too. Because this one has a pen feature. That's what I was going to use. You want the outline of this object to where it actually starts. Now I'm using my mouse to do this, so I'm not very good at this. Wow, is that bad or what? Look at that. That's horrible. Oh, erases the whole thing. All right, let's try that one more time. And we go across and down.
You want to go higher because you're going to put the slots into it?
Good point. Absolutely right. I'm trying to draw this with great inaccuracy, as you could tell on the screen. That's this basic shape. It looks absolutely horrible. Kind of looks like a dinosaur without its front legs. But you actually want to close this off, or a little doggy with its tail. And you are correct. You should close that off. So what you're really trying to make is the whole shape. So if I look at, you want to make this entire shape. If I fill it in, it won't be too filled in, but it'll be filled in, roughly filled in. See that? You want to make this entire shape. And that's going to be your sketch. Okay? So now I'm just going to erase everything to get it all out of the way. That's what you're focused on making. So when you're over here on this side, the first thing I recommend you is throw in a center line. Your center lines should be through the center of your axis. That is going to be the center of this, just like it has a center line. If you look over here, it has a center line right there. See that? That's that center. Everything is dimensioned off the center. If I now draw in some lines, they're going to be lines. Let's say I draw a line there, there, off at an angle. I don't know, draw this line straight down, go down here, across, up. It is not dimensionally accurate if you haven't figured that out yet. I'm drawing a very, very rough drawing, really rough. Here, here. By the way, this is where the power of parametric comes in, because I can draw in such a haphazard manner, and then I can get serious about my dimensions and start cleaning up this thing. The overall height of this object from up here to down here, the height of this object is 3. How do I know that? Because that's what that says right there. So the overall height is 3. Okay. Next dimension, I can focus in on this side. The width of this, the smaller dimension is 1/8. So the dimension from here to here is 0.125. The dimension from out here to there is 1/4 inch. So from here to here, whoops, to here is 0.25. Okay. The outside dimension from the center to out here. Now watch. This is where things change. Up to this point, and let me show this one more time before we miss this little detail. When I pick a center line, 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 and then pick the side wall of something. Okay, let's try that one more time. When I pick the center line and the side wall of something, if I stay on that side, I have a radius. If I move my mouse past the other side of the center line, I get diameter. I get diameter. And in this case, that's what I want, because the outside diameter of this object is 6. So I don't have to sit there remembering what's the radius of 6. Yeah, I know half of 6 is 3. That's not the point. I'm trying to show you how you can avoid having to even reference that. Okay? And you can rinse and repeat this action for every single item in here. So if I go from here to here, this diameter, that inner hole diameter, now that specifically gives a diameter. It says diameter 0.56 through. You notice that? That's probably the only object I don't want cut through, to be honest. Only because I want to actually make it a hole. Why? For the same reason I've suggested using the hole command in the past. So that when you do your detail drawing, you'll have this detail drawing option. If you make it part of your feature, you'll never have that as your option. Okay? You'll never have that as your option. You'll manually have to do it. So I'm actually intentionally picking my center line and that object so I can do collinear. This object, we want it to be vertical. So now the question is the dimensions from outside to the center. This diameter of the outer body is 1.75. How do I know that? It's right there. Did I pick something wrong? Not yet. Oh, darn it. All right, I'm working on it. Okay, the dimension from here to here. This dimension is 1.25. Okay, so that's good. That's this dimension here. So that's the inner diameter. The inner depth from here to here, this depth is what, guys? Yep, 0.75. You got it. 3/4 right here. Oh, I knew that was coming up. Sorry. Now this guy here, we're going to drag this dimension. Whoops, hold on. You got to drag this down. You got to drag this down. Objects will start messing up now, so you got to have to move them a little bit. This object from here to here is 0.25. This inner body from here, this inner shape in here, is parallel to this. So therefore it's parallel to this, and therefore its diameter is this. Because they're parallel, I can just pick this object. I can pick this vertical line, hold my control key down, pick this vertical line, and pick collinear as their matchup. So they line up with each other. That's quite messy right now, but that's all right, we're getting there. It's slowly taking shape. I know, the humor is really bad. So now down here, now we have 1 point, let's see, what's it, 1 point, no, it's 0.75, right here, 0.75. So my dimension from the bottom to this object, let's try that one more time, the bottom, come on, we can do it. There we go. That dimension is 0.75. And the same dimension from here to here, let's try that one more time. From there to there, that dimension technically is 1, but hold on. The way they dimensioned it isn't the way that got to delete that. So I had the crossing window to delete it. They want the dimension here, 1/4 inch, 0.25. So that's in there. This angle right here needs to be incorporated into this drawing. That's not right now. So I can pick this line and this line, and it finds angle. You don't have to specify angle or anything. That's 15 degrees. This inner shape is parallel to it, here to here. These two shapes need to be parallel, which they now are, but this needs to be down here, not up there. So the last thing needed is this dimension here that tells you the thickness, and the thickness is 1/4 inch. But I don't get that. What do I, okay, I do, 0.25. That's the thickness of that. So now we've got everything identified except what? There's a few things missing. We need this step identified from here to here. That's 0.09 based on the drawing that's right there. And then we need to identify this radius, which is the distance from here to here. That's 4.5. And now, at the bottom, it'll say fully defined. When it's fully defined, you're done. There's nothing else you can add. Now the last step for this object under features is to revolve. Because the center is already there, it automatically revolves. So then you end up with this thing. Looks kind of okay, right?
Doesn't not revolve 360.
Yes, it does. It's by default, it's 360. If you want it to be less than 360, you can identify that. So if you didn't want it to go 360, and let's say you only wanted to revolve 45, you can pick 45, and that's all it will do. And then you end up with a little creature that's missing its front legs. It's going to fall on its beak.
And we go too slightly like a sketch.
I'm sorry?
We go too slightly like a sketch.
You can do whatever angle you want. So if you want to do 270, it doesn't matter. But that's not what this part is sectioned for you. This part is not made to this shape. You can tell that this part is presented this way so that the user can use it to make the drawing. It is not physically built like this. It shows a sectional line in here. See these hatch lines all in here? All those hatch lines? That tells you it's a sectional view. The part itself is not made to that specification. Okay? So you do build it. You build it to the full size, 360. Your detail drawing is where you section it. You don't ever section it in your model. Okay? Never section it in your model. So now you have this, but there's some issues. It's got sharp corners. See? See how this has nice little radius corners there? It's got nice little radius corners in there. See that? Of course, they're complementary on this side because this thing's round. And you need these cutouts right here. It looks like a little castle top. You need those cutouts in there. Okay? So we got to put those in. The radii are not identified to the best of my knowledge, except here. Okay? It says all unmarked radii is 0.13, which is 125. Now you'll notice I did not put them in beforehand, because a radius of 1/8 of an inch on the outside for a 1/4 inch thick part would actually add significantly to what the interior radius would be. But because they did not say the inside radius, this inside radius here, is not bigger than this radius. They're supposed to be the same. That is a reason why the radii were not put in up front. They're going to be machined as a secondary operation. You're going to use the fillet command. You're going to type in 0.125, and you're going to pick these inner radii and this outer one out here. And you're going to say, okay. And that's how you get that look, as far as that look is concerned. The last thing we got to put in here, now I would make that the last action. Fillets are usually the last thing I ever put in a drawing. I don't really put them in this early. So what I'm going to do is roll this up so the fillets go away. Yeah, I am lazy. I'm leaving them in there. I'm going to go to my front view, for example, and you have a cut right in there. There are 2 ways to make these slots. There's 2 ways to make these slots. See this? This is a cut in this direction. If I was going to use a mill, whoa, that came out bad. If I'm going to use a mill, like an end mill, like a cutting tool, I would just slice across and do this in one shot if I had the right tool, or I'd nibble away at it to get that right shape. Okay? Now, my machinist, would you just drop the depth, or would you mill across down to the depth? Or would you just go through the side wall? Probably mill down. You'd probably mill it before you put that hole in it, I imagine, right?
Yeah.
Mill the slot in before you put the hole in, right? Before you even put this interior hole in. This would be a next operation. So there's a lot of things when we think about how would we build this versus how would we draw this in CAD. To build this, I'd have this as a secondary operation. I'd be doing the red slots first, and then I'd be drilling that interior shape, and then of all things, let's find what colors we have. Nah, not red, so we got red up there. We're gonna go with fuchsia. Then I would drill this as my last hole. See that? I'd make the slots first, the red slots. Let me erase the other stuff so you can see what I'm talking about. If I was going to physically machine this, I'd probably do the red slots first, then I would drill the blue hole down to a particular depth, and then I would drill the purple hole through. Thoughts? Or would you do the purple one first and then the blue? See all these questions? And a lot of that is just your efficiency on your piece of equipment that you use. Everybody's different. Okay? What you would use. Everyone's different. Okay? That you'll figure out in the field. I'm not going to try to second guess how they're going to do it. But the nice part is it doesn't really matter how I build it here. Sometimes it does make it more beneficial depending on how I build it to make it more efficient in the CNC. But I'm not teaching CNC for this class. I want you to learn how to build anything, so I'm not going to worry too much about how I'm going to CNC it. Because it might be 3D printed for all you and I know. It might be a casting. We don't know. We don't know what manufacturing process we're going to use on this yet. So back here, I've got my basic shape, but I don't have the cutout. Okay? So I can go ahead and add that in. I can pick that face and go to Hole Wizard. Am I ready for that, or should I do that next? Or should I cut the slots in? See how it doesn't matter which way I go. See how I'm doing that to you? The next step isn't fully defined. For fun, I'm going to make the X, but I'm going to do it a different way than maybe you even thought I would. Of all things, I'm going to start off the top view. I'm going to start off the top view. Literally, I'm going to pick this top face, and I'm going to create a sketch on the top face. And I'm going to literally do a convert entities and pick my outer shape, and that's it. I'm going to have this outer shape. Now I'm going to go normal too, so I can look at this head on. And I'm going to draw a line on this side. I'm going to draw a line on this side. I'm going to draw a line across. Let me get back.
Draw a line on top of the center line also.
No, I don't want, because I'm just doing a different way. I don't want to draw a line in the middle.
So then you're still going to the center.
This way, watch what'll end up happening. I'm going to draw these two dimensions here. And I'm going to make sure that says 0.25. And then I'm going to make sure I drag this over. I'm going to drop in this dimension here. So I can take this dimension and divide it by 2. Okay? That way it centers it. The reason I did that, by the way, is so that when I do my detail drawing, I'll get these options. They'll appear. The dimensions will automatically appear that way. Now, mathematically speaking, these lines are a very specific length. So if I did a match properties, as in I said you and you and you, I want all of you to be equal, they'll all size up together. So one dimension, these two dimensions are driving the 4 sides. I can, if I want to, trim the middle, or I can leave it. Doesn't matter. What I have is a grid, this shape. Now I can actually go to features and extrude cut. Don't forget that one. Now this is where life gets a little interesting. You actually have to pick what you're cutting with. Okay, see how that happened? Now notice, on 2 sides I picked double bars, and on the other 2 sides I just picked the perimeter the edges. Doesn't matter. In the end, you're going to have the same kind of cut. The question is, how deep is that cut? There it is, 1/2 inch. 0.5 is the depth of the cut. 0.5. When I hit OK, that's what I get. 1/2 inch cut. Okay, you'll end up with an object that looks like that. I guess then unsuppress the fillets, and let's see what else. Right, was that it? No, I'm missing something. Am I missing anything? Is this wide enough? Quarter inch? Yep, that's what they want. Yep, we're fine. So the last thing I gotta put in, what did I miss, guys? I missed this, the hole. So I go there. Hole, now notice, remember, please remember. Pick the face first, then go to Hole Wizard. Hopefully I said that loud enough, just to remind you. Okay? That's important. As far as hole, let's see what they got. They got an ANSI inches. Let's see if they have anything close. We need a through hole. All drill sizes. Let's say show decimal values, since that's what I'm seeing. 0.56, which is 5625. 9/16 diameter hole. Okay, go to position. Sorry, I think I accidentally clicked on something else. There we go. Go to position and drop it right in the middle and hit OK. There's your hole. And we are done. That ends this lecture. Or remember